A very good day. My name is Siu Kai-en, metric number A20A2271. We are from class L1T2, group 4, and this video is to present our group assignment. First, what is data? Data refers to symbols that can record and identify objective events. It is a physical symbol or a combination of these physical symbols that records the nature, state, and relationship of objective things. It is a recognizable and abstract symbol. Then, what is a dataset? Dataset is a collection of data, usually in the form of a table. Each column represents a specific variable, and each row corresponds to a question of a member's dataset. Next, let's talk about the data that we use in this assignment. The data we use is a secondary data which outlines the fertility rate by age group and states in Malaysia 2016, retrieved from Department of Statistics, Malaysia. Our variable of its interest is fertility rate, which can be viewed from the perspectives of different fields that are state and age group.
My name is Nurul Fazila Akmal binti Ismail. My metric number A20A1859. First, data arrangement. Class-wide can define as the difference between the upper limit and lower limit. Frequency table. Frequency table is a table that shows of class the entire data into class. From table 1, the frequency for the first class 1 to 31 recording the highest score 50, while the second class until third class, which is 31 to 62, 16.3 to 19.3, recording the same frequency, which is 4 respectively. The first class 94 to 124 shows frequency which is 3. The fifth class, which are 125 to 155, show frequency which is 4. For the table, the sum of the frequency for each class is 28. The cumulative frequency can define as the sum of the data entries for each class for a previous class. From the table 2, the frequency for first class of data 1 to 31 is 13. The graph our data is histogram, and I'll give our cumulative frequency graph. A histogram is a bar graph that represents the frequency distribution of the data set. Lastly, I'll give our cumulative frequency graph is a graph that shows the cumulative frequency of each class at the upper class boundaries.
Hi and Assalamualaikum. My name is Muhammad Asri bin Yaakob. My metric number is A20A2162 and I represent the numerical descriptive measure. Numerical descriptive measure is divided into 3 ways. Measure of central tendency, measure of position, and measure of variation. First, measure of central tendencies. There are 3 measures of tendencies for ungrouped and group data, mean, median, and mode. So the mean is the sum of the value of each observation in a data set divided by the number of observations. This is also known as the arithmetic average. So the mean of the fertility rate by age group and states was approximately 57. Median is the median value in distribution when the values are arranged in ascending or descending order. About 50% of the fertility rate are below 39.25 and the other 50% of the fertility rate are above 39.25. The last mode is the data entry that occurs with the greatest frequency. The highest fertility rate by age group and state is 19.82. Second measure is measure of position. There have several measurements of position which include quartile, percentage, and standard score. First, percentage are the method of measure the position of entire data by dividing the data into 100 equal parts. The value will be divided a rank order set of elements into 100 equal parts of data. Next, quartile. First quartile is cutting of 35% of entire data, while the second quartile is cutting the data in half of 15 percentiles. The third quartile is cut of highest 35% of data. for our case is group data, so we can conclude that the 25% of fertility rate by age and state is less than 17.19, while 75% fertility rate in Malaysia is more than 93.5. From the value for third quarter, 17% of fertility rate in Malaysia is less than 93.5 and the 25% fertility rate is more than 93.5. For the inter-quarter range is 76.31. The last measure is measure of variation. They have several measurements of variation which range, variance and standard deviation. First, the range of data is different between the maximum and minimum data entries in the set. And the range for this case is 151. Next, variance. The second technique in measure of variation is variance. Calculative variance involves squaring deviation. Therefore, it does not have constant unit of measuring because the original observation. And we can conclude the sample variance of fertility was obtained by age and state is 2206.33. And the last method is standard deviation. Variance is that the measure of unfold most employed in applied mathematics practice once the mean is employed to calculate central tendencies. And we can conclude the sample standard deviation for the fertility is about 56.97. Thank you.
Assalamualaikum. My name is Nur Izzah Afifah binti Abdullah. My metric number is 2081746. I want to present about statistic analysis using SPSS. First, numerical descriptive measure. The mean using SPSS for the number statistic for fertility rate by age group and state Malaysia 2016 is 53.04, while the mean by using manually calculate is 56.96. The median using SPSS is 40.50 and using manually is 39.25. The mode in using SPSS is 1 while using manually is 80.82. Standard duration for SPSS and manually calculate are different with 1.008 and variant is different about 95.558. The range, minimum and maximum value for calculated by SPSS and calculated manually are same, which are 151, 1 and 152 respectively. The percentage using SPSS for quarter 1 is 7.50 and for quarter 3 is 91.50, whereas using manually calculate is 60.19 for quarter 1 and 93.5 for quarter 3.
Next, hypothesis testing. Using the t-test have 5 steps. Step 1, state null and alternate hypothesis. Step 2, level of significance. Step 3, SPSS output. Step 4, decision rule, reject hash null, and critical reject. Step 5, decision. Reject hash null. Therefore, we can conclude that mean is not equal to state and age group. Using ANOVA has 5 steps too. Step 1, state null and alternate hypothesis. Hash null equal mu1 equal mu2. Hash 1 equal at least one of the mean is different from the others. Step 2, significant level. Alpha equal 0.05. Step 3, SPSS output. Step 4, decision rule. Reject hash null if F more than F alpha. Critical region, F alpha equal 2.57. Step 5, decision. Reject hash null. Therefore, this is significance different among the treatment. Correlation analysis. Step 1, hypothesis. Hash null. There is no correlation between age group and fertility rate. Hash 1, there is correlation between age group and fertility rate. Step 2, significant level. Alpha equal 0.05. Step 3, SPSS output. Step 4, decision rule. Reject hash null if p-value less than alpha. Step 5, decision. fail to reject hash null sin p-value more than alpha. We can conclude that there is correlation between age group and fertility rate. The last one is confidence interval. By using SPSS, the result on above shows the lower boundary 34.43 and the upper boundary 71.64. The standard error for this dependent is 9.067. Therefore, it can be said that 95% confident that the population parameter is between 34.43 and 71.64.
I'm Nur Zulaika binti Zabidi and my number matrix is A20A2230. I'll be presenting for theoretical modeling. Multiply linear regression is the most common form of the regression analysis and used to predict the outcome of a dependent variable and two or more independent variables. Here is the model. Y equal to B0 plus B1x1 plus B2x2 plus B3x3 plus B4x4 plus E. Y is the dependent variable. B0, B1, B2 are parameters, x1 and x2 as constants, and E the error terms. In the study of our sample data set, Y is fertility rate and two independent variables, state is x1 and age group is x2. In correlation table, the R value between state and fertility rate is 0.002. Age group and fertility rate is negative 0.154 and both are less than 0.3, means that fertility rate is not associated with both state and age group. R value between state and age group is 0, which is might have relationship between these two, but it's not linear. Perhaps there is no problem of multicollinearity. Next, for the Shapiro-Wilk test of normality on the residual give a p-value 0.008, which is less than 0.05. The assumption of normality of the residual terms is not met. In model summary table, the R-squared value is 0.024. Means 2.4% of the variation in fertility rate can be explained by age group and state. From ANOVA table, we can see that p-value is more than 0.05, which is 0.742, means that the two variables, age group and state, cannot be used to model price. Lastly, from coefficients table, we have concluded the final equation, which is fertility rate is Y equal to 67.250 is B0 plus 0.100, state is B1x1 minus 3.616, age group is B2x2. From the equation, when state and age group are 0, the fertility rate will go up by 67.250. Thus, for every increase in state, fertility rate will increase by 0.100, age group remain unchanged. Similar for every unit increase in age group, fertility rate will drop by 3.616 and state remain unchanged. Lastly, p-value for state is 0.991 and age group is 0.445, which is more than 0.05. Thus, state is not a significant predictor of fertility rate. The 90% confidence interval for state is negative 17.052 and 17.252. Age group is negative 13.204 and 5.972.
From the report that we had done, we know that all statistical can be done by our data, that which is with 28 samples that including two fields. In conclusion, for graphical representation, we use histogram and OGIF because our data is quantitative data. For numerical descriptive measures, we compare the result between manually calculation and SPSS output, and only range and maximum and minimum data entry are same in manually calculate and SPSS output. In hypothesis testing, we use t-test and we conclude that mean is not equal to state and age group, and by using ANOVA test, we conclude that there is significant difference among the treatments. Besides, we perform correlation analysis by a scatter plot and correlation table, and we found that 95% confident that the population parameter is between 34.43 and 71.64. For theoretical regression, we construct a theoretical regression model of multiple linear regressions. By referring the coefficient table from SPSS output, we conclude that 2.4% of the variation in fertility rate can be explained by age group and state. And from the test of normality table, the assumption of normality of the residual terms is not met. Lastly, we got the equation which is fertility rate equal to 67.250 plus 0.100 state minus 3.616 age group.